Every radio you own, your car stereo, your phone, the public safety repeater that keeps first responders connected, traces back to one man. Not Marconi, not Tesla, a kid from New York City named Edwin Howard Armstrong. He didn't invent one thing, he invented three. Three of the most important circuits in radio history. And by the time he was done, the industry he built those circuits for had turned on him. This is the story of how it happened. The rise. Edwin Howard Armstrong was born on December 18, 1890, in Chelsea, Manhattan. He was the eldest of three children. At age 8, he contracted Sydenham's chorea, what used to be called St. Vitus's dance, a neurological condition brought on by rheumatic fever. It left him with a physical tic that worsened under stress. It would haunt him for the rest of his life. In 1909, at 18 years old, Armstrong enrolled at Columbia University to study electrical engineering under Professor Michael Pupin at Hartley Laboratories. What happened there would change radio forever. Radio in 1912 was barely functional. The triode vacuum tube existed, but it couldn't amplify much. Listeners needed headphones. The signal was too weak to drive a speaker. Armstrong, still an undergraduate, solved that. He developed the regenerative circuit, feeding part of the triode's output signal back to its input, amplifying it hundreds of times beyond what anyone else had achieved. For the first time, a radio could drive a loudspeaker. And he discovered that the same circuit could oscillate, turning the vacuum tube into a transmitter. This wasn't an incremental improvement. It was the difference between radio as a curiosity and radio as a mass medium. Armstrong graduated in 1913 and filed for the patent. U.S. Patent 1,113,149 was granted on October 6, 1914. He was 23. In 1917, the United States entered the First World War. Armstrong served as a major in the U.S. Army Signal Corps, assigned to a lab in Paris. There, he invented his second foundation of modern radio, the heterodyne receiver. It worked by mixing the incoming radio signal with a locally generated signal, producing a fixed intermediate frequency that was much easier to amplify and filter. It was more sensitive, more selective, and more stable than anything that had existed. The superheterodyne is still the standard receiver circuit in radio today, in your phone, your car, in public safety repeaters and handsets. A circuit designed in a Paris war lab in 1918 is still running the world a century later. Armstrong filed for the patent in 1919 as he left the Army. 1 year later, in 1920, Westinghouse purchased the regenerative and superheterodyne patent rights for $335,000, with an additional $200,000 contingent on Armstrong winning a patent dispute that was already brewing. That dispute would haunt him. Meanwhile, Armstrong kept working. He developed a third invention, super regeneration, even greater amplification, greater distances, greater sensitivity. He sold it to RCA in 1922 for $200,000, plus 60,000 shares of RCA stock, which was later increased to 80,000 shares. At the time, Edwin Armstrong was the largest individual shareholder of RCA. He was just 32 years old. But the patent dispute was coming for him. Lee DeForest, the inventor of the Audion triode tube, had filed competing regenerative patent applications claiming priority from an August 1912 notebook entry, months before Armstrong's recognized date of January 1913. The Patent Office held an interference hearing. The D.C. District Court ruled for DeForest in May 1924. Armstrong appealed. The U.S. Supreme Court upheld DeForest in 1928. He appealed again. In 1934, the Supreme Court upheld DeForest for a second time. Armstrong lost. The patent he had sold to Westinghouse, the one that made radio loud, was legally attributed to someone else. The IRE Medal of Honor he had received in 1917 for the work was, according to the Supreme Court, awarded for an invention that wasn't his. Armstrong tried to return the medal. The IRE board refused to accept it. They reaffirmed Armstrong as its rightful owner. The engineering community overwhelmingly sided with him, but the law did not. That loss taught Armstrong something he never forgot. Courts could take his inventions, and it made him stubborn. He would never settle cheaply again. At the start of the original court case, around 1928, Armstrong began researching something new, something that would become his greatest contribution and his greatest burden. He started working on frequency modulation, FM, in secret in the basement of Columbia's Philosophy Hall. At the time, amplitude modulation, AM, was the king of radio. AM works by varying the strength of the radio wave to carry sound. The problem is that static, from thunderstorms, electrical equipment, anything that creates electromagnetic noise, shows up as variations in signal strength. AM radio literally cannot tell the difference between music and the noise. That's why AM radio sounds the way it does. Armstrong's idea was different. Instead of varying the wave strength, FM varies the wave's frequency. Because most noise is amplitude-based, an FM receiver can strip out that static and keep the signal clean. And Armstrong discovered something that nobody expected. By making the frequency swing wide, what he called wideband FM, the noise rejection was dramatically better than anyone thought possible. In 1922, an AT&T engineer named John R. Carson had published a mathematical proof that FM was no better than AM. He was right, but only for narrowband FM. Armstrong's wideband FM shattered that limitation. After 5 years of secret research, on December 26, 1933, Armstrong was granted 5 U.S. patents covering the fundamental features of wideband FM. 1 year later, he was appointed professor of electrical engineering at Columbia University. But patents on paper don't change the world. Armstrong needed to prove FM worked. In May 1934, he began field testing from an RCA laboratory on the 85th floor of the Empire State Building. The test ran through October 1935. FM signals reached 80 miles with crystal clarity, no static, no fading, no interference. RCA's engineers were impressed, but RCA's management was not. David Sarnoff, RCA's president, had known Armstrong since 1913, but by the 1930s, Sarnoff had committed RCA's future to television, not FM. He had hoped static could be eliminated with the simple add-on to existing receivers. FM was too complex, too disruptive, and too threatening to RCA's AM empire. RCA told Armstrong to remove his equipment. He packed up and left. In May 1936, Armstrong published his findings in a landmark paper, a method of reducing disturbances in radio signaling by a system of frequency modulation, in the Proceedings of the IRE. The title was long. The content was revolutionary. It introduced the world to frequency modulation. Then, in June 1936, Armstrong demonstrated FM at the FCC headquarters before roughly 500 engineers. He played a jazz record over an AM radio. Static sat on top of the music like a blanket. Then he switched to FM. The same record player at the same power, but it came through as if the band were in the same room. No extraneous sounds. The engineers heard the future. Armstrong decided to take FM public with his own money. He built the first FM radio station, W2XMN, later renamed KE2XCC, in Alpine, New Jersey. His 40 kilowatt transmitter operated at 42.8 megahertz. The signal was heard 100 miles away. He funded it himself. By January 1941, the FCC officially recognized the commercial FM band, 40 channels at 200 kilohertz each from 42 to 50 megahertz. FM was real. Nearly 400,000 FM receivers had been sold by the end of 1941. Companies like GE and Zenith were paying Armstrong a 2% royalty. Armstrong was a professor at Columbia, a major RCA shareholder, and the inventor of the technology that was going to replace AM radio. He was at the top of the world. In 1940, RCA offered Armstrong $1 million for a non-exclusive, royalty-free license to FM. $1 million in the middle of the Depression. Armstrong refused. He refused because accepting would have betrayed GE, Zenith, and other smaller companies already paying royalties. It would undercut every licensee who had signed a fair deal. It wasn't about the money, it was about principle. That decision shaped the rest of his life. If you want to know how the story ends, how the industry he helped build turned on him, how the government moved his frequencies and made 400,000 radios obsolete overnight, and how it all ended in the 13th floor apartment in Manhattan, that's the next episode. But if you've enjoyed this one, subscribe. The next part of Edwin Armstrong's story is the hard one to tell.